Welcome back. Thanks for joining us for another episode. We have a lot of ground to cover, so we're going to get right into it. This episode's all about software vulnerability mitigations. Like I said, we've got a list. So I want to start by talking about cross-site scripting. What do you say?
Cross-site scripting. I like cross-site scripting. I mean, for me, as an attacker, it's great. For you, as my client, probably not so much.
Yeah, the victim has not such a good time.
Yeah, it's not great. So what can we do to help stop this? Well, you got to remember, what is cross-site scripting? How that works is allowing the user to input something, and that becomes a part of a statement somewhere and is interpreted as HTML, JavaScript, so on and so forth, right? So we want to stop that from happening. I will say, many of the mitigations we're going to talk about today are going to include the number one with the bullets under this rubric: stop trusting user input. Write that down. Do not trust your users. They may be your grandmother and you love her to death, but just because you can trust grandma doesn't mean you can trust other people. Mm-hmm. And since you can't control many of these systems on who does stuff with them, you are asking for input from randos on the internet.
That's true.
You need to not trust them.
And even if you do trust somebody, like you don't think they're going to do something bad intentionally.
Right, like they're a user or whatever.
Is it possible that they might just accidentally put something in that's like breaks things?
Even if they didn't, right? Even if there was no way to accidentally put something in, like you had to purposely do this, what if someone gained access to their login?
Right. Exactly.
Now they are the threat actor, and that's
but it's not them. Right.
But it's not them.
Okay.
Right? So we don't trust user input ever.
Okay.
Okay?
Makes sense.
That's where it starts. So what does that mean? How does that work out mitigation style? Sanitization, right? What kind of characters are you giving me? So if you're throwing me HTML characters, I should be able to sanitize that and go, that's no bueno. We don't allow that. Take it out. Chuck it to the fire, right? Anything that might look like JavaScript. So all those JavaScript characters, you would want to go, you don't need that.
Yeah.
We're going to take that out.
What are you doing with that?
Yeah. I feel like that's not necessary. So you should have filters in place, regular expressions in place to kind of look for those characters that would be unsafe, as it were, and remove them from there. Output encoding can also be another helpful, right? So if one of those sneaky little suckers makes it past your filter, or you don't have one installed at all, well, it'll just go, hey, that looks like an unsafe character. Let me go ahead and just encode that for the output, so that way it doesn't get rendered by your browser.
Okay.
Triggering that cross-site scripting, right? One of your really good ways to go about this, use a WAF.
Yeah.
A web application firewall will go, hey, sucker, that's not cool. That's cross-site scripting, because it's pretty well known. I mean, you got to get really tricky nowadays to like really uncover using those like XSS polyglots and stuff to kind of uncover cross-site scripting, because WAFs and good regular expression sanitization does a pretty good job of filtering all that stuff out. Another thing you can do is just use safe syncs, right? You have sources and syncs when it comes to websites.
Right.
Stop using things like inner HTML as a sync, right? Use like text context or value instead. These are safe. We don't have to worry about the same. It won't allow for a cross-site scripting situation if you use those as your syncs. So there you go. There's cross-site scripting.
So that's cross-site scripting and kind of some ways that we can maybe prevent that from happening to us, right? So then there's also the idea of overflow vulnerabilities. What do we mean by that?
So these are buffer overflows, right? Buffer overflows. So really easy, SAST and DAST. That's the first thing out of the gate. Remember, this is a programming problem. This is not I implemented the wrong security measure, I didn't have the right ACL, whatever. This is a problem with the code that runs an application. So static application security testing and dynamic application security testing is going to be key here on finding where those are before they are a problem. And then we can remove that, refactor, recode, make things nice. Also, teach your programmers to use safe coding practices. Send them to training, do whatever you have to do so that they understand, hey, don't use gets in your C code or whatever, right? That's an unsafe thing. Don't use Python pickles. I know, it's funny.
It is funny. Right? I'm sorry. I'll focus.
Yeah. And what's the other thing? That kind of like parlays into the next thing, kind of rolls into the next thing, which is heed the warnings that your compiler is telling you when it goes, hey, you got puts here. Probably don't want to do that, right? It will warn you, and with known security issues, read documentation. It has hey, this is a known security vulnerability. You probably don't want to put this in production.
Okay.
Right? So if there are warnings that are happening from either your compiler or in documentation, you should heed that stuff.
Yeah.
And don't use that. Substitute it for a more secure library, function, method, whatever the case is.
They'll just like ignore it. Like, no, it's fine. We know what we're doing.
Yeah. So a lot of times done is better than perfect.
Yeah.
Right? You have a deadline you're trying to meet, and I don't have time to refactor this. I need this to work so I can ship it.
So don't sacrifice the security of your code just to get it done.
That's right.
Okay.
You stand up and say, hey, that's an insecure practice. Yeah. We should not do that.
That makes sense.
And then make your voice known that, like, that's an issue. And, of course, if we're on the other side of it, kind of going back the other way, hey, from now on, we don't do that because that can cause issues.
What about the idea of stack canaries?
Yeah, these are good ideas when it comes to overflows, right? Because when you do an overflow, a lot of times what ends up happening is, as an attacker, I'm going to place my arbitrary code into the stack, and then that gets executed instead of whatever's supposed to be there, right? So if we put stack canaries in, it basically just took a random value that we place at the stack at runtime. So when that memory is called, it goes, okay, here's a canary. That's where it goes, right there. Should be the first thing in there.
Okay.
Right? And then anytime it's called again, it's checked, is it still the canary there? If it's different, like when I overwrite that with a buffer overflow, it'll go, whoa, there, the canary's not there. It's overwritten.
Huh. Is this where like maybe comes from the idea of having like canary in the coal mine?
Yes.
Okay, that makes sense.
Right. It's the first line of defense to know that there has been a problem.
Okay.
And then it just kind of errors and shuts off.
Interesting.
Yeah. Oh, well, okay. Something went wrong. We're just going to go ahead and back out everything and close down, and you figure out what's wrong. Come back when you got that figured out.
Okay.
So if I was trying to commit a buffer overflow, it would just error and kill the service or the process or whatever it is.
I love these naming conventions that they have. It makes it so much easier for me to remember, and it's just so much fun.
Yeah.
So then there's also data execution prevention, which is a Windows thing, right?
Yeah, it's usually built. Well, there is a Linux version of it. It's called no execute or NX.
Oh, okay.
As well, it basically just makes the stack non-executable.
Makes sense.
Right? So if you know that there are memory areas that do not require, they're basically like registers, or just holding information or whatever, and there's no reason that it should be executable. You make it non-executable. So in Windows, that would be through DEP. In Linux, that would be through NX.
Okay.
Right? And then one of my favorites is address space layout randomization, or ASLR. We can actually kind of take a look at that. If I've got Immunity Debugger up here. This is I'm running a program through it here. And if you look over around this region, you can see these are memory spaces.
Okay.
For each one of these assembly code processes or functions, right? So like this is a move, and it's telling you to move to the EAX, which is a register. Okay, and this is where that resides. If that is static, every time I fire this up, and that memory space is always the memory space that is called to do that move, well, that's a known variable. And if I can control the flow, and I'm able to manipulate what is in this 7723 2B50 memory space, and I change it from move EAX to whatever I want it to do, that's good for me. And now I have repeatability. That's one of the things about buffer overflows is if this memory space changes, well, then I have to account for that. And my buffer overflow might work once, but it won't be consistent.
Okay.
Right? So we use ASLR to make sure that that's what happens.
Okay.
If you can't predict where I'm going, you can't create proof of concept that I can now give to Sophia and I can give to you.
Right. Okay. So those are some ways we might take action, I guess, to prevent against those overflow vulnerabilities or buffer overflows, like you said. Okay. Yes. Good to know. So cross-site scripting, buffer overflows, or overflow vulnerabilities. Then we also have this, which I think is maybe relatively new, relatively speaking, I guess, as AI and machine learning becomes more prevalent.
It's probably something new as far as like in that you need to worry about it now.
Right, exactly. Yeah, I guess that's what I was kind of going for.
It's not new, it's just now you need to.
Now it's relevant.
Now it's a problem for you.
So this is the idea of AI data poisoning.
Yes.
So what does that mean?
So with AI, to train AIs, you give them data sets, right? You feed them information, right? In a machine learning or AI models. And they use that to, if you have AI, to figure out new things, and ML to make decisions.
Right.
Okay? So this would target their availability and their integrity, because what you're going to do with data poisoning is feed it bad data. This is
Okay.
intended to produce incorrect outcomes,
Okay.
right?
Gotcha.
So maybe if I'm in, or I want a specific outcome, or I want to poison an outcome so that it doesn't give you the information that you want, but I don't want you to have, I would poison your data set. I would feed it some information, either through standard network hacking. I would hack into your system, drop in the data that I want into your data set's area, and it would ingest it and go, huh, okay, that's new truth for me, and I'm just going to accept it because it came from God,
Right.
right?
Okay.
And
That makes sense.
That's where it is.
Huh.
It won't know any better. It's just really hard to detect.
So then what are ways that we might be able to mitigate that?
So we have to start looking for weird things, right? So you can run different checks. Basically what they call this is outlier detection, anomaly detection. You're looking for those weird things. I think sometimes you'll hear it referred to as data sanitization.
Okay.
So you kind of check those data sets. Everything should kind of like, if I have oranges, if I'm trying to compare apples and oranges and train the machine to know the difference between apples and oranges, and all of a sudden there's a banana in there and it's being told that's an orange.
Yeah. Red flag. Yeah.
Right? Like, what is this over here?
Mm-hmm.
And
Seems wrong.
And you look into that, right? One of the mitigations we use is called human in the loop. We use our eyes. We test with ourselves, and we go, because we're much better at seeing anomalies in certain ways than the machine would be, right? It because it's accepting it as truth.
Right. Okay.
Okay. So, and then of course, standard security methods. If I poisoned your data set through hacking into your server and dropping poison data into the data set, well, then you need to secure the server
Right.
from me hacking into it. And
That-
that's
yeah.
the mitigation.
The standard stuff that you usually would want to do anyway,
That's
right? Okay, that makes sense. Interesting. So that is, I mean, that's new to me at least. So good to know. But looping back to something that maybe is a little bit more familiar, we're going to talk about broken access control.
Broken access control. One of our favorites. Starting to, this is always one of the more fun ones. Usually ends up on the OWASP top 10. But here are some things you can do to try to help mitigate that. Default deny, except from your public resources, right? So if something is trying to access things that it shouldn't access locally, that should be a default deny, right? If it's coming from public, and then you might have a use case for that where it needs to access certain things. But if it's local, no, you don't need access to this.
Yeah.
This is kind of the idea behind like SE Linux, where it just builds walled gardens around things. And if you don't need access to it, you don't get access to it. There you go.
I don't need to know basis.
Minimize your cores usage. This is cross-origin resource sharing. So the less I do that, the less likely that is to be abused.
Okay.
Honestly, that's just a good rule of thumb when it comes to security. Do less of the things that you want to decrease your attack surface.
Okay.
Right? That's what it's all about. The threat landscape should be as small as humanly possible.
That makes sense. Yeah.
Disable things like directory listing, because if you don't know there's an asset there to look at, it's going to be hard for you to exploit it.
Yeah.
So don't give it away, right?
Okay.
Move sensitive files out of your web root. So if anything holds passwords, usernames, anything that might be sensitive that if someone were to stumble across that's in the web root itself, well, they shouldn't be seeing it, or move it somewhere else, so they would have to know where that folder is. Again, it's kind of a security through obscurity thing, but a layered defense is a good way to go. It's always, again, another good rule of thumb. Make sure you're logging and alerting to any access control failures, because then you can pick up on if someone's trying to brute force their way into something and that kind of thing. You get an alert that says, hey, we picked up there's some increased activity on trying to access the HT access file or something.
Right.
So
Okay.
stop them from doing that. And then enable rate limiting so that if they are using some sort of automation, that it will severely cripple that and decrease its effectiveness from being able to automate that process, and now it slows it way down.
Okay. So then that's broken access control. We also want to talk about cryptographic failures, which I would imagine is that like either you're not using encryption or the encryption you're using is really weak.
I would say that if you're not using encryption, that is a failure.
That's true.
It's just very
Failed
few,
somewhere, yeah.
Very few cases in today's day and age where cryptography or using encryption is not on the table. And not only that, but it's standard. But it happens.
Yeah.
Like, oh, well, I'll just use FTP here. Why? Because it's FTP. Yeah, I get it. But I mean, there's secure FTP and there's SCP and there's too many secure options that are just as easy and readily available. So
Yeah. Why not?
why not?
Yeah.
So yes, to Sophia's point, use encryption. Otherwise, you are failing. All right, let's move on. What else can we do? Make sure you classify all your data. That you have sensitivity levels. You need to say, well, this is top secret, and this is for public, because then I don't have to worry about accidental exposure. People can see, oh, if I were to build a system that accesses this file, and it's top secret, I'd make sure that that's not public facing.
Yeah.
Right? That's going to be behind some sort of authentication. And not only that, but I want it encrypted so that when you do access it, you remember this is encryption is at rest, in motion, and if possible, in use.
Yeah.
Okay? So we want to ensure that that is occurring. If it's not, we need to take a look at how we've designed this thing and make some changes. And use the strongest encryption possible. Don't use encryption algorithms that are known to be weak.
Yeah.
Right? Use a cryptographically secure pseudo-random number generator for any initialization vector. Right? So that's another important thing. Don't just use some, mom and pop random number generator. Use one that is cryptographically known to be secure.
Okay. Yeah. Interesting. That you made that a lot clearer than I thought it was going to be. So thank you.
Ultimately, it just boils down. Use the strongest encryption.
Use the strongest encryption possible.
Yeah.
Don't fail us.
Yeah.
So then we want to talk about injection flaws as well. And I know you talked about this kind of earlier as far as like a way you can maybe prevent against this, sanitizing user input. You talked about that with cross-site scripting, right?
Yes. Sanitizing user input, this definitely falls down because remember with an injection flaw, I'm injecting information. You are giving me an input. As a user, I can give you input. Who's to say I don't give you some jacked up input?
Yeah.
Right? So we sanitize that so that only thing we get is what we expect to receive.
Right.
The machine should never receive anything it doesn't expect. And if it does, it should go, I don't know what that is. Let's try again.
Yeah. Okay.
Right? So filters go in place. You remove those dangerous, because think of something like SQL injection. What's the big character we use for SQL injection? Do you remember?
Single quote?
Single quote, right?
All right.
There's no loud single quotes because there's a filter in place going single quote bad.
Yeah.
What else you got?
Get rid of that.
All right, I have the rest of this. It's fine. That's single quotes going in the garbage. Right? Filters, sanitization. That's what we're doing. Then, of course, there's prepared statements and parameterized queries, specifically for things like SQL injection. This is very helpful. So prepared statements are statements that you have prepared beforehand. So if Sophia wants to make a query to the database, there's not a dynamic query being built in the background with the data that she's inputted. And if there's SQL injection in there, then bam, now we've built a SQL injection.
Yeah.
Right? It just goes, what do you want to do? You know, just, okay, I got that statement right here. Run it. Right?
Okay.
It's prepared. Then you have parameterized queries, which is kind of like where you build something dynamically, and then the other half of that is kind of like a prepared statement.
Okay.
So it puts those things together, keeping, again, it's passing values to query, and then it acts like a prepared statement. So once it has only the pieces that it needs, the rest of it is already prepared.
That makes sense. Okay.
And then it passes it along.
All right. Injection flaws. Makes sense.
Injection.
Very straightforward.
Yeah.
So then we also want to talk about cross-site request forgery and how do we mitigate that?
The big one you really need to take away from this is just use CRSF tokens.
Okay.
Tokening system will help keep those things, because it kind of breaks out your session into two things. Not everything is handled in the cookie. Some of it's handled by the CRSF token. And that's much more difficult to perform cross-site request forgeries when that is occurring.
Right. Okay. There's also the idea of directory traversal. And is this, you talked earlier about like disabling directory listing. Would that come into play here as well?
That would come into play right here, right? So directory listing is going to show you what's in a directory. Whether or not that stops directory traversal, I would say maybe not.
Okay.
I say actually, I don't think that has anything to do with it.
Oh, okay. Gotcha.
It seems related.
But not really.
But not really. Directory traversal is where I can back up from wherever I am in the directory.
Right.
And then drill back down.
So you want to prevent that?
And I do that using certain characters.
Okay.
So we're going to do some
Input sanitization?
Input
All right.
sanitization, right? I don't allow those characters,
Right.
which is a ...
Okay, gotcha.
right? And the variations thereof. Don't forget variations. There's always variations.
Always, yeah.
So you got to account for those variations. Then another thing you can do, append a root directory to all API calls. So tell it, this is where you start. So it's always like programmatically appending that root directory to whatever call is being made to the API. That kind of like, I can have ... till the cows come home, but it's going to think it starts here.
Yeah.
Because I appended that before the call was eventually made.
Okay.
That's one good way to go about it.
So that's directory traversal. I know we're running short on time, but we have a few more we want to get through.
Let's
so
crank. And then
we'll crank
ultimately, a lot of it's pretty simple.
Okay.
Right?
Okay. So there's insecure design.
Yeah.
Seems pretty straightforward.
So secure design is the way that you mitigate that, right?
That's true.
Use proper coding practices, secure implementations, and that kind of thing. Make sure your logic vets out into, you got to think securely. When you're designing a system, make sure that the logic works and that it works in a secure way.
And then also security misconfiguration. That comes up a lot, right?
Right. Don't configure things insecurely. Right. It seems pretty straightforward. But what I mean is like when you create that file, don't put read, write, execute everyone. That's a security misconfiguration.
Yeah.
Right. Force authentication for access to certain areas. Don't make it to where, well, if you didn't put in it, you can just type in the URL and it goes.
Yeah.
Right.
Don't default to that.
These are the kind of things that we mean.
Yeah.
Use ACLs. You whitelist, deny list, blacklist, accept list, whatever you like to call them. Implement these things. Put those things in a secure way. Encryption is being used. All that stuff, right? Kind of everything we've been talking about, honestly, falls under security misconfiguration. If you don't do them, you have configured this. Change defaults. Move things around. Make sure passwords are secure. That kind of stuff.
We probably also want to avoid using like outdated components as well, right? If we can.
Yes, absolutely. That's one of the things they want you to do is like if you're using something that's at end of life or is already outdated, then you need to upgrade to the latest and greatest thing. If you can't, that does happen, right? That does occur. This is where you need to implement some sort of secondary security control.
Right.
So if I've got a device that's got like a, embedded Linux on it, it's like an IoT thing, we'll put a firewall in front of it that says, this is the only traffic in or out, nothing else goes.
Yeah.
Right. And only from here, right? You got to get really granular with the control on what can go in and what can come out. So to help mitigate down the possibility someone could exploit a vulnerability in it if you can't upgrade.
Right. If you can't update or change that outdated component, you got to do something else to kind of make up for that.
They call it compensating controls or secondary controls. Yeah.
Okay. That makes sense. I've heard that before. I know those words. So then also another thing that can present some problems is identification and authentication failures, right?
Oh, yeah. Yeah. Obviously, this can be an issue. An authentication failure could be the fact that I used a SQL injection to bypass a login, right? That would be an authentication failure.
Okay.
So any way that we can improve the identification of our users and their authentication mechanisms. So if you're not employing things like 2FA, employ 2FA. Again, these are kind of common practices now that if you're like, oh yeah, that just seems like new and exciting, so we haven't implemented it yet. No, it was new and exciting 5 years ago.
Right.
Now it's required.
Now it's a standard.
Yeah.
Yeah.
You should be doing that.
The bare minimum.
If it doesn't have that mechanism, find some way to compensate for that and implement something. CAPTCHAs, you name it, something that continues to push verification of their identity and what it is you're using to authenticate with.
There's also the idea of server-side request forgery. How would we mitigate against that?
Firewall probably wouldn't be the best way to go. ACLs, just say, I don't allow for this. You can also use things like proxies.
Oh, okay.
Proxies, so the proxy sends a request instead of you, and therefore it can get sanitized, making sure it comes from the right source.
Okay. And then there's remote code execution. This is an area where maybe that sanitizing input would come in handy again.
Sanitizing user input is the mitigation of the day, is it not?
It is.
So always, because what is remote code execution? I am feeding code remotely to the system. The system should be able to go, I noticed you have something that looks very similar to code here.
Yeah.
I'm going to remove that because I don't think you need that.
I don't need that.
And so we're going to take that out.
Come on in, sir, but leave your code at the door.
Other things you can do is secure application memory management. This is again in a coding practice. This kind of all falls in it. But you can also inspect network traffic to kind of check for those things. So next-gen firewalls and stuff like that can kind of help with those types of activities. But there you go, some mitigations there.
There's also privilege escalation. How would you prevent that from happening?
This is really difficult. Obviously, we keep things up to date. Software updates are going to be one of your biggest things. So a good update schedule is going to be the name of the game here. Any stop using components with known vulnerabilities, because that could lead to that. A lot of it's going to come from all the other mitigations that we talked about here, because privilege escalation can come from a myriad of different sources.
Right.
It's so vast and far out there that it's ultimately a holistic view of security, and implementing all these security strategies are going to help keep privilege escalation from being a problem.
Okay. And then finally, we've reached the end of the list. Last but not least, we have remote and local file inclusion. I know.
Remote and local file inclusion. Well, don't allow for file inclusions.
Yeah.
There's that. Turn that off. Or you could sanitize the user input.
Again.
Because if you're looking for files that the system should not be looking for, like Etsy password or .ini or something like that, then that should go, hey, I see what you're doing there, and I'm going to ask you to just go ahead and stop right now. So just pull that out. A web application firewall will also be able to check for and go, hey, that looks like a file inclusion exploit. Let me go ahead and put the kibosh on it.
Okay. Well, I know this was a little bit of a longer episode, but covered a lot of ground, lots of good information on software vulnerabilities and some mitigations that we can take advantage of to prevent that stuff. So thank you for running us through that, and thank you for joining us for this episode. We'll see you next time.